This is a video to help you think about conditional probability distributions. So first, let's look at a joint probability. So let's say there's two random variables, y and x can be -1, 0, and 1, and y can just be, let's move this up, y can be 0 or 1. So we're thinking about the chances of each of these pairs of things happening. So what we have here is it's saying the chance that x is 1 and y is 0 would be 0.05. So let's just write this to represent the joint probability that x is a 1, y is a 0 is 0.05. So keep in mind that means they both occurred. So in contrast, this one's a joint probability. It's telling us about the chance of a particular outcome for x and a particular outcome for y. Now, the chance of x alone being -1 is the outcome of only one of the variables. So that is found by adding the chance of xy when x is -1, y equals 0, plus the chance of xy, x equals -1, y equals 1. So if you remember from stats, you might not have used this notation most likely, but you already know that this becomes the marginal probability of x, that these are 0.2 plus 0.3. So this is 0.5. So the marginal probability comes from summing these. And so we can see the chance of x equals -1 is 0.5, the chance that is 0 is 10%, and the chance it's 1 is 40%. So this is the marginal probability for x. And similarly, you can do that for y, that there is a 25% chance that y is 0, while there is a 75% chance that y is 1, and summing across the probabilities for y, it's only a probability distribution if the sum of all the probabilities equals 1. Okay, so what we're going to do with this that's important in econometrics is we're going to think about conditional probability. In other words, I want to know the chance of x for x given y equals 1. Okay, so what's the probability of x given y equals 1? This means any of the x's are possible. What x's are possible are still -1, 0, and 1. And I want the chance of that x given y is 1. So to find those probabilities, we're going to use the conditional probability rule, which says the way that you find this is the chance of xy for a given x and y divided by just the chance of y. So what does this mean? So for this particular one, I need the chance that of xy, x is a -1 and y is a 1. So I go up here, x is a minus 1 when y was a 1 was a 0.3. And it needs to be divided by just the chance that y is 1. The chance that y was 1 is a 0.75. So this conditional probability is the and in the numerator and just the chance that y is 1 in the denominator. And if I divide those two, I'm going to get, that's going to equal 0.4. So there's a 40% chance that, given I already know that y is 1, that x is going to be in minus 1. I can go ahead and complete the others. The chance that x is 0, given y equals 1, comes from the chance x is 0 and y is 1, which is a 0.1, but also divided by the chance of y equals 1, which is the 0.75, which becomes 0.13 repeated. So this is a 0.13. And let's complete the last one. What's the chance that x is 1 given y is 1? The chance that x and y are both 1 is 0.35. Divide that by 0.75 and we're going to get a 0.46 repeated. So this is 0.46. So if you take a look, this is a proper conditional probability distribution function, because it tells us, given that y is already 1, what is the probability of each of those x outcomes. We can also verify that the sum of the probabilities sums up to 1. So this complete thing is a conditional probability distribution function, and each of these separate things are each just a particular conditional probability.